All right, everybody. It's the last lesson of the unit. This is where we kind of put everything together, okay? And we graph functions that have vertical asymptotes, horizontal asymptotes, points of discontinuity. Okay, so just a quick reminder, vertical asymptotes are what make the denominator 0. Right? After factoring. Okay, that's the first step you do in all these questions you're going to see is you factor everything. So whatever is left over in the denominator after you factor is the vertical asymptote. Horizontal asymptote. Remember, these are the three rules that you need to remember. If the degree n of x is the numerator, which is the top, is less than the degree of d of x, which is the denominator, which is the bottom. So if the degree of the top is less than the degree of the denominator, then the line y is equal to 0 is your horizontal asymptote. In other words, if it looks something like this, x squared over x cubed, all right? Degree 3, degree 2, therefore y is equal to 0 is your denominator. If they are equal degrees, it's the leading coefficients. So if you have 2x squared plus 5x plus 1 over 3x squared minus 1, you don't care about any of that stuff. You just look at the degrees of these two things. They're the same. So the equation of your horizontal asymptote is 2/3. And if you want to know why that is, take calculus. If the degree of the numerator of the top is greater than the degree of the denominator, it has no horizontal asymptote. So if it's x cubed, 3x cubed over 4x squared, you just say no HA. Again, take calculus if you want to know what happens with those. There's different types of asymptotes, but you probably don't care. All right. And then remember, have a factor in common. In other words, the factors cancel. So that is a point of discontinuity, POD, or a whole graph. So that is something like x plus 2, x plus 1 over x plus 2. The x plus 2's cancel. You also have x plus 1. That means you have a POD at x is equal to -2. It's whatever makes that factor 0. And then to find the y value, you plug -2 into what's left over. So -2 plus 1 would be -1. So the actual coordinates would be -2, -1 in that case. Okay. The steps are fairly simple. First step, factor. Factor. You want everything to look like this. All these little brackets, okay? Simplify by canceling, like we did there, and then plug in your x value into what's left over to get your POD, okay? So let's do a practice one. So we're basically skipping most of this lesson. We're going right to the end. Doing this one right here. Okay, this is on page 476, the last one of this lesson. So we're going to sketch this graph. Algebraically determine the equations of any asymptotes, blah, blah, blah. State the domain range. Basically, graph. That's really what matters. Okay. Okay, so the top is already factored for us, which is nice. So we should factor the bottom. Okay, so the bottom quadratic multiplies to 15 and adds to -2, multiplies to -15. That's going to be x minus 5, x plus 3. So right away, you can see the x minus 5's cancel. And you're left with 2x minus 1 over x plus 3. Okay, so before we start graphing it, we can write out some vertical asymptote. What makes the denominator 0 after you've canceled and factored everything? X is equal to -3 is my vertical asymptote. Horizontal asymptote. Now this one, it doesn't matter if you use the original or what's left over, you get the same answer. So in this case, we'll just use this as a degree of 1 there, degree of 1 there. So since they match, we just use the leading coefficients. So it's going to be 2 over 1. The horizontal asymptote. You could write 2 over 1, but most people would just write 2. We also know that POD was the number that canceled. X minus 5 canceled. Whatever makes that 0 is our POD. And that is x is equal to 5. If you want to know how to get the y value of that, plug it into what's left over. The y value is going to be 2 times 5 minus 1 over 5 plus 3. 2 times 5 is 10, minus 1 is 9, plus 9 8. So the actual POD right down here, coordinates 5 and 9 8. Bit of a weird number, but whatever. I'm also going to ask you to tell me the x-intercept, which is when y is 0, and the y-intercept, which is when x is 0. Okay, so for the x-intercept, let's do y-intercept first because it's actually easier. All you do is put x is equal to 0. Now, it doesn't matter if you do it to the original or you do it to the one that we simplified. I'm going to do it to the one that we simplified because, well, it's simplified. It makes it easier. If I put 0 in for x, this whole top goes away except for -1. If I put 0 into x at the bottom, I'm just left with 3. So my y-intercept is -1/3. That's it. Easy enough. X-intercept is when y is 0. Again, you can do it in the original, or you can do it in the simplified version. Simplified version makes it easier because if I put y is equal to 0, remember this is y equals. So I can 0 is equal to 2x minus 1. And you solve for x. Now, if you think about it, you're going to multiply that up there, which would be 0 times that, which is 0. So the only thing you ever have to look at when you're trying to figure out your x-intercepts is the factors of the numerator. So I'm left with 0 is equal to 2x minus 1. Move the 1 over, divide off the 2, 1/2 is equal to x. That is your x-intercept. Okay, we have our x-intercept, our y-intercept, vertical asymptote, horizontal asymptote, and POD. We can sketch the graph. So mark all your points. Okay, so x-intercept is at 1/2. Y-intercept is -1/3. Scale is going to be a little off here, people. Is -3. Yes, that's where -3 is. Horizontal asymptote is 2. Y is equal to 2. We have a POD at 5 and 9/8. So 5 would be somewhere out here. 9/8 is less than 2, so just mark a hole there. All right. Now, you cannot touch the vertical asymptote. You cannot touch the horizontal asymptote. For what you'll see in grade 12, if you go on, there are times you can cross a horizontal asymptote, but for right now, just pretend you can't. And so the graph has to come up through those 2 points and go through the POD. Now, that's 1/2 of it. You got to look at everything on this side of the vertical asymptote. If you don't know where it's going to be, In other words, you don't have another data point. Pick a number that is less than -3. So just -4. Doesn't matter what it is. It could be -50,000, does not matter. Put it into your function. So if I put -4 into here, I'm going to get y is equal to 2 times -4 minus 1 or -4 plus 3. That's going to give me -8 minus 1 is -9. -4 plus 3 is -1, which gives me 9. But -4, I'm at 9, which is somewhere up here. It doesn't matter. All that it matters is that it's bigger than 2, because that's the horizontal asymptote. And so the graph cannot touch the vertical, can't touch that. So I know it has to look like that. Okay. Now we're going to do some more examples of this. I'm not just going to give you one example. So I've got some blank paper for writing. Here we go. We're going to graph. Oops. Sketch y is equal to 2x minus 4 x minus 1. All right. So first thing, can you factor? Yes, I can factor 2 out of the top. That's all I can do. Nothing cancels. Okay. So vertical asymptote, what makes the denominator 0? That's x is equal to 1. Horizontal asymptote, leading coefficient, the degrees are the same, 1, so it's the leading coefficients. That's y is equal to 2. There's no POD, there's nothing canceled. We can find our x-intercept. That is when y is equal to 0. And a number for the x-intercept, all you have to do is look at the numerator. In this case, it'll be x is equal to 2. That's what makes the bracket 0. The y-intercept is when x is equal to 0. So if you put 0 into either one of these functions, if I put it into this one, this goes away and that goes away. I'm left with -4 over -1, which is just 4. All right, we have all our information. Vertical asymptote at 1. Horizontal asymptote at 2. X-intercept is 2, so if that's 1, x-intercept has to be there. Y-intercept is 4. That'll be a fifth. Everything's done for you. You don't have to test any points because you cannot touch the horizontal or the vertical, so you know your graph has to look like that. And same for this one. We have a up there, so like that. And that's it. All right, let's do a slightly more complicated one. Y is equal to x squared minus 3x minus 4 over, let's write it out in factored form, x plus 2, x plus 1, x minus 1. All right. So first step, factor the top. What multiplies -4 and adds to -3? X minus 4 and x plus 1. All right. Anything cancel? Yes, the x plus 1's cancel. So I'm left with this. Okay. All right. So after that, you figure out your vertical asymptote. What makes the denominator 0 after you factor? We have 2 of them, -2 and 1. Horizontal, look at the degrees. So if you multiplied out the bottom here, you would get x squared minus x plus 2x plus x minus 2. You get that. The degree at the bottom is greater than the degree of the top, which is 1. Therefore, is 0. Okay. X-intercept is 4. And POD. POD is what cancels. So that is x is equal to negative 1. And if you want to know the value of y at the point of discontinuity, plug it into what's left over. Okay, so y is equal to, let's plug it into here, negative 1 minus 4, or negative 1 plus 2, negative 1 minus 4. So I'm going to get negative 5, negative 1 plus 2 is 1, negative 1 minus 1 is negative 2. So I'm going to get 5 over 2, or 2.5. The POD has coordinates of negative 1 and 2.5. Okay. All right. So the graph here, mark down everything. So horizontal asymptote of 0. Right along the x-axis. The vertical asymptotes of negative 2. And 1. There we go. And the x-intercept of 4. So that's 1, 2, 3. Yes. Okay, so this is a bit weird because we have an x-intercept on a horizontal asymptote. That is okay. All right. Like I talked about, you can cross in some cases. I will not give you graphs in the future that do this. This was a bit of a mistake by my part, but that's okay. All right. We have a point of discontinuity at negative 1 and 2.5. So just guess where 2.5 is. There's 2.5. And we have a y-intercept. Do we have a y-intercept? I did not calculate the y-intercept. Oh, well, let's go calculate the y-intercept. Y-intercept is when x is equal to 0. So if I put x is equal to 0 into this one, or this one, or this one, it does not matter. X is equal to 0 into this one, that goes away, and that goes away, and that goes away. I'm left with negative 4 over negative 2, which is the x-intercept is below that one at 2. Okay. So let's sketch this graph. All right. If you don't know, like if you don't have any information, like over here, just pick a point that is less than negative 3. All right. Well, what's a point that's less than negative 3? Negative 4. If you put negative 4 into this function, you're going to get negative 4 minus 4 over, no, actually I'll use this, negative 4 plus 2, negative 4 minus 1. That's going to give me negative 16. Negative 4 plus 2 is negative 2. Negative 4 minus 1 is negative 5. All I really care about is that this answer will be negative. I'm going to get negative 16 or negative 10, or a positive 10, sorry. Which is going to give me a negative 1.6. So at negative 4, we're at negative 1.6. Remember, it has to sit in this region, so you know the graph is going to look like this. Okay? This part of the curve, you have to go through this point of discontinuity. You have to go through this point here. You can't touch anything else, so the only thing it can do to come down, scoop through those. It's like a little parabola. It's smudged in between those three things. And for your guys, for Math 12, for every graph you're going to see, look, it's going to go this, and then, well, 99% of them, it'll be in this quadrant. They sort of alternate in a zigzag. That's not always the case. And if you're not sure, again, just pick a point. This is 4, it's our x-intercept. But pick another point. This is 1, so pick the point 2. Test where it is. Is it up here? Is it up here? Or is it down below? Okay. Well, if I use x is equal to 2, and plug it into this guy, I'm going to get y is equal to 2 minus 4, 2 plus 2, 2 minus 1. 2 minus 4 is negative 2. 2 plus 2 is 4. 2 minus 4 is 1. That is going to be a negative number, negative a half. So at 2, we're at negative a half, so we're down here somewhere. So the graph looks like goes through that and then goes like that. Okay. My apologies, that one is not really fair because it did cross the asymptote, which the ones you will see will not. All right, I'm going to attach a bunch of practice ones for this. You could, if you wanted to, go on the assignment. You can do this one. You can do that one. Actually, not if I do that. Don't do that one. You can do that one. That one. Definitely these two. Actually, just focus on D, E, F. That'll be good. And you can sketch them and just use Desmos to check your answer because they don't have the actual graphs in the back here. Okay, so just do number 1, D, E, and F. If you want extra practice, I'm going to attach some sheets that have practice like the ones you will see on the assignment. All right, that is it. Thank you, and that is the end of the unit, a very, very short unit. All right, talk soon. Bye.